allowing for floor expansion and shrinkage. In this module, we will examine the properties and effects of floor movement. Floors move because timber expands and contracts in response to seasonal variations in humidity and temperature. We will cover 3 areas of movement in this module: shrinkage and swelling due to changes in moisture content, why expansion allowance is a must, not an option, and expansion allowance in fixed and floating floors. Timber is hygroscopic, which means that it responds to changes in the moisture content of the air. Timber absorbs moisture when exposed to humid air and releases it when exposed to dry air. This process can cause seasonal fluctuations in the width of a timber board. The diagram on the left examines how these fluctuations occur through different humidities. Solid timber flooring is generally manufactured with a moisture content of 10 to 11%. A board that is manufactured with this moisture content at 80 millimeters wide will stay this width under a relative humidity of 60%. However, if the relative humidity changed to, say, 80%, then the board will absorb more of the moisture from the air, causing it to expand. Conversely, if the relative humidity dropped to 40%, the board would release some of this moisture and the width would shrink. The map on the right outlines the variations in humidity that occur at any one time across Australia. Humidity could be at 40% in one part of Australia and 80% in another. Manufacturers produce boards with a moisture content suitable to the average humidity in the location they are to be used, which aims to minimise the effects of seasonal changes in humidity affecting the boards. The photos here show the similarities in appearance between 4 different types of hygroscopic flooring, from solid timber, engineered timber, laminate flooring to strand-woven bamboo. As they are all hygroscopic, they will all experience the effects of expansion and shrinking during their lifetime. And although they look similar, the extent of their movement will vary significantly. To understand the hygroscopic properties, we first need to understand moisture content. To determine the moisture content of a piece of timber, we need to know the difference between the dry weight of the wood after it's kiln dried and the weight of the wood with moisture in it. We then know the weight of the water inside the board. Multiply this figure by 100 and we have the percentage of moisture content in the timber. The example in the diagram here shows the formula in action. To visualise the moisture content, we can equate a 12% moisture content of a piece of timber to 0.12 kilograms of water per 1 kilogram wood. For an 80 millimetre wide timber board, a moisture content change of 1% will generally result in about 0.25 millimetres of expansion or shrinkage. This puts into perspective the magnitude of the shifts a timber board can experience through changes in humidity. We will go into more depth about measuring moisture content in another module, assessing timber and concrete moisture. As we mentioned in our comparison earlier, different types of timber flooring will experience different amounts of moisture-related movement. Because of their differing properties, they will also experience different types of directional movement. A solid timber board has a grain running along the length of the board, which causes the board to expand mostly in width and very little in length. An engineered timber board is a composite of timber sheets with different grain orientations, which help to restrain movement. Laminated flooring is made of high-density fibreboard, HDF, which has no specific grain direction, so the board can expand unpredictably and disproportionately. Expansion joints are necessary to ensure a timber floor can react properly to the changes in board width. Clients and designers may not like the look of expansion joints in flooring, but they exist in many facets of construction and can be detailed to avoid an unattractive aesthetic. Expansion joints are not an option, but a necessity for timber floor to allow for movement. They are required by both industry standards and manufacturers' requirements. It is important to understand why we need expansion allowance. The main reasons are moisture content testing is not completely accurate. Meters are only accurate to within plus or minus 2% of the actual moisture content. Moisture meters can deliver unreliable readings for some products. Properties can differ between the manufacturing and in-service environment. Predicting in-service conditions is uncertain and can be difficult. And the climate varies unpredictably throughout a year and over the course of many years. The first photo shows the effects of a floated engineered floor that has not properly allowed for expansion. As you can see, the timber boards have buckled off the subfloor. The second photo shows a solid timber floor that has been fixed to a plywood subfloor with an adhesive. Insufficient allowance for board movement, coupled with a poor method of fixing the plywood to the joists, has resulted in the entire floor buckling off the joists. The third photo at the bottom left shows a bamboo floated form buckling beneath a door. The bamboo's expansion in length hasn't been allowed for, and the result is a buckled floor. The fourth photo shows what can happen when a timber board expands lengthways. The end joints have been exposed to expansion pressure that they can't endure, causing the end joints to raise. For a solid timber floor, an allowance around the perimeter of the flooring is necessary to allow for movement. A 10mm expansion gap, ideally a clear air gap, will provide adequate clearance for expansion. A cork gap may be used in some instances, though problems have been found using cork as a gap filler around window joinery. The expansion gap is then corked, covered by a skirting board or thin aluminium strip. For wider floors of 6 metres or more, an intermediate expansion gap is also required. A cork expansion gap of 10mm at the midpoint of the flooring will provide enough allowance, or alternatively, regular smaller gaps throughout the width of the floor can be more successful in high humidity areas. The photos show a floor that has used both a cork filler and regular interval gaps along with a clear perimeter gap. Sports floors are often a sprung floor system, as in this example, where 2 sheets of plywood have been fixed together and the lower sheets have had rubber pads fixed to them. The flooring has simply been stapled to the plywood with no additional adhesive. Small gaps between the flooring boards have been placed at regular intervals between 400mm and 800mm apart. Throughout changes in humidity, these gaps will physically come and go due to changes in board width. The photos show the elements used in allowing for expansion. The top photo shows the plywood sheets being oriented with different grain directions over a black plastic moisture membrane. The photo on the bottom left shows the rubber pads fixed to the bottom of the plywood to give it spring. The bottom right photo shows the regular expansion gaps every 8 boards. Here, we consider expansion allowance for pre-finished solid and parquetry floors. Pre-finished solid flooring uses perimeter allowance the same way a site-sanded or coated solid strip flooring would, though no intermediate gaps need to be used. With many parquetry floor designs, where patterns have blocks at right angles, even very wide floors generally do not need intermediate allowance. Allowance is provided to the full perimeter. In the photo, we see where a cork joint at the walkway between 2 larger rooms has been added. Now we move on to the allowance required for engineered timber and bamboo floors that have been directly fixed to the subfloor. Engineered flooring moves much less in width than a solid timber floor, but does experience some lengthwise expansion. Perimeter expansion gaps are used to account for this, but only in a very large floor would an intermediate gap be necessary. The same is true of strand-woven bamboo, which generally only requires an intermediate gap when covering a much wider floor. Perimeter gaps would sufficiently allow for lengthwise expansion of the bamboo. However, bamboo is now less often directly fixed to the subfloor. For a floating floor, the boards are not fixed to the subfloor beneath them. Instead, they are fixed to each other, creating a separate or floating panel of flooring called a raft. Therefore, it is movement of the raft that needs to be accommodated. Rafts can experience significant movement, as the boards making up the raft can all individually expand in width and length. This diagram shows a floor broken up into 3 distinct areas or rafts. As you can see, the expansion or shrinkage of one raft can be independent of another. Compartmentalization is the process of breaking up a timber floor into a number of smaller rafts joined together by expansion or control joints using trims. This process allows the rafts to shift independently of each other. Without this process, the movement of one raft could upset the movement of another, resulting in buckling, separation at board joints and gaps at skirtings. Heavy objects, for example kitchen benches, cannot be laid on top of floating floors, as it inhibits raft movement. The images show a control joint across a doorway and a scotia around a kitchen bench. Although expansion trims come in various designs and appearances, there are 3 basic trim types that are generally used for floating floors. The end trim is used between adjoining floor surfaces at the same height or along sliding patio door tracks. The H trim provides a low profile joint with the floor acting as a control joint, creating a clean aesthetic, whilst also allowing for both expansion and contraction of the floor areas either side. The T trim provides a transition between 2 floor surfaces of different heights. During installation, it will angle itself to cater for the height difference and will also allow for floor movement. The importance of providing movement and control joints in floating floors cannot be overemphasized. From an expansion perspective, joints are needed to prevent buckling. With moderate shrinkage and insufficient provision being provided, floors can pull out from beneath trims and at times they can separate mid-floor. Now we have covered the essentials of allowing for floor expansion and shrinkage. Let's summarize what we've learned. 1. It is important to understand that timber flooring products are hygroscopic and that when moisture content changes, the board dimensions will change too. 2. Providing expansion allowance and control joints is a necessity, not an option, when laying all timber floors. 3. Different flooring types require different expansion allowances. Following the correct method for a certain floor type is crucial for the longevity of a floor. 4. For solid timber flooring, the movement is primarily linked with the movement of individual boards. With floating floors, boards are joined to each other and it is the movement of the raft of flooring that needs to be considered.